Section 9.2. Solve quadratic equations by using the quadratic formula. So the quadratic formula comes from deriving it by completing the square with ax squared plus bx plus c equaling 0. I showed you the steps, so I do want you to be able to follow them to see how they came up with the quadratic formula. Well, to complete the square, the first thing you had to do is subtract the c. Then, because the number in front of x squared wasn't 1, they divided everything by a. And then completing the square says take half of the b term, so b over a, but divided by 2, and then square that. So that gives you b over 2a quantity squared that you would add to both sides. And then this factors into x plus b over 2a quantity squared, and I just rearranged this. B squared is b squared, and 2a is 4a squared, minus c over a. Then I found a common denominator, which is 4a squared, and so that turned into b squared staying the same, and then minus 4ac to make a common denominator. Then I took the square root of both sides, so the left side, the square and the square root cancel, and the right side becomes b squared minus 4ac all over the square root of that, and the square root of that is 2a. And then I subtracted over the b over 2a, and that's how they get the quadratic formula, just by completing the square. You will never have to do that in this class, but I did want to show you where the quadratic formula came from. So you do need to have this memorized. Make sure you understand it's all over 2a, so don't make the line be short or too long, but it is this whole side all over 2a. So how are we going to use the quadratic formula? Well, first of all, get rid of fractions. It's much easier if you don't have fractions, so multiply by the LCD. Combine like terms and put it into the form of ax squared plus bx plus c, so everything on the same side equaling 0. I'd also make a positive to make your life a little bit easier. And then just plug in a, b, and c into the quadratic formula and simplify. So when you hear the word quadratic, you do need to think of an x squared. And we had different ways to solve quadratics. The way that we learned back in section 6.4 was we factored. But now not everything's going to be factorable. We learned the square root property in 9.1, and we learned how to complete the square in 9.1. And then in this section, we're going to use a quadratic formula. Now, when would you use a quadratic formula? Well, we use it when factoring is not easy, like some of y'all might not like that AC method, or if it's not possible. So make sure you understand factoring is not always going to work. So let's look at some examples. Solve using the best method of your choice listed on the previous page. So I'm not going to jump to the quadratic formula unless I have to. So for example, on number 1, x squared plus 5x minus 6, I see that I can factor that. And that's just going to factor into x plus 6 and x minus 1 equaling 0. So then I said each factor equal to 0. So either x plus 6 would have to equal 0 or x minus 1 would have to equal 0. So x would equal negative 6 or x would equal 1. So my two answers are negative 6 and 1. So I would not jump to the quadratic formula for number 1. But looking at number 2, we have 3y squared plus 10y minus 8. When you look at that, you might think, okay, I could try the AC method, but some of you might not like the AC method so much. So let's try the quadratic formula instead. Quadratic formula says, first of all, make sure you don't have any fractions, and we don't. Everything is on the same side, so now we know what A is. A is 3, B is 10, and C is negative 8. Now, just so you know, this is factorable, but we'll assume that it's not, or that we don't want to do it, because the AC method sometimes is a little challenging. So I would write the quadratic formula every single time. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. You must write x equals for the quadratic formula. Now look what variable we're using. We're using y. So now we're going to start off with y equals. And negative b, so negative 10 plus or minus the square root of, always put b squared in parentheses. When you're doing your substitution, use parentheses. Minus 4 times a, which is 3, times c, which is negative 8, all over 2 times a, and a is 3. So y is going to equal negative 10 plus or minus 4 times 3 is 12, and 12 times 8 is 96, so we get plus 96 all over 6. So we get negative 10 plus or minus the square root of 196 all over 6. Now some students might think they're done, but you have to see if you can reduce the square root of 196. And you can. The square root of 196 is 14. So I'm just going to come over to this side now, and we're going to have y equaling negative 10 plus or minus 14 all over 6. All over 6. Don't stop there. You're not done. Because your radicals completely disappeared, you should be able to break it up into the two answers. Negative 10 plus 14 divided by 6. And the other answer is negative 10 minus 14 divided by 6. So negative 10 plus 14 is 4, and 4 divided by 6 is 2/3. And negative 10 minus 14 is negative 24, divided by 6 is negative 4. So my answers are positive 2/3 and negative 4. So since you have no radicals, that meant this actually was factorable from the beginning. So if you didn't like doing the quadratic formula, now go back to number 2 and try the AC method. You'll still get 2/3 and negative 4. All right, number 3, a squared plus 4a. Let me see if this can focus a little bit. All right, a squared plus 4a plus 1 equals 0. If we try and factor it, there are no factors of 1 that add up to 4. So your factoring is out. You cannot. You could try completing the square if you want, but you can't do the square root property. However, we could do the quadratic formula. So writing the quadratic formula again, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Again, write the equation down every single time and you'll remember it better. So I know this is kind of confusing, but a is 1, that's in front of a squared, b is 4, and c is 1. So we're going to plug these into a, b, and c now. And our variable that we're using was a. So a is going to equal negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1 all over 2 times 1. So we get a equals negative 4 plus or minus the square root of 4 squared 16 minus 4 times 1 is 4 times 1 is 4 all over 2. So a is going to equal negative 4 plus or minus the square root of 16 minus 4 is 12 all over 2. Now we can't stop there. We're going to have to simplify even though our radical doesn't completely disappear. So remember, 12 is 4 times 3, so that means a 2 can come out. So right now we have a equaling negative 4 plus or minus 2 square root of 3 all over 2. Now here's where students make a lot of mistakes simplifying because they're not sure how. So my suggestion is always separate each one over its own denominator, and then you would have no problems simplifying. So put negative 4 over 2 plus or minus 2 square root of 3 over 2. And now simplifying each one, we get a negative 2 plus or minus square root of 3. Students make mistakes because they just want to cancel one side and not the other. So if you separate them, you won't have any issues with not canceling correctly. So on number 4, the first thing we probably need to do is bring everything over to the same side. So I'm going to add over the 8x, and I'm going to subtract the 2. So I'm going to end up with 3x squared plus 8x plus 7 equals 0. You could try the AC method, the quadratic formula. I'm going to give you the answer so you can come back and try this one on your own. But a is 3, b is 8, and c is 7. And you are going to have a negative under the radical. So you're going to end up with x equaling negative 4 over 3 plus or minus I squared of 5 over 3. Again, I'm always going to separate each one over its own denominator and simplify. So see if you can get that answer for number 4. Alright, on number 5 we have 2x squared plus 10x equaling 0. Well, I would not do the quadratic formula. This is just GCF. Take out a 2x, and I'm left with x plus 5 equaling 0. Set 2x equal to 0, or x plus 5 should equal 0. Divide by 2, so x would equal 0. Subtract the 5, so x would equal negative 5. So again, we have two answers, 0 and negative 5. So what I want you to realize is if you're left with radicals, factoring was never going to work. So you would have stayed here forever trying to factor this and it would not be factorable. but we can still solve it. So make sure you know how to use the quadratic formula well. So on number 6, if you look at the directions on what we want to do to try and use the quadratic formula, is to get rid of our fractions. So the first number 5 and 2 can both go into is 10. Remember, this is 2 over 1. So our LCD is going to be 10, so I'm going to multiply everything by 10 over 1 to get rid of fractions. So when I multiply by 10 but divide by 5, I get 2x squared. And 10 times 2 is 20, and 10 times 1 but divided by 2 is 5x. So I'm going to subtract over the 5x, so I get 2x squared minus 5x plus 20 equals 0. Again, you could try and factor, but it might not be factorable to begin with. So let's go ahead and jump to the quadratic formula. I'm going to let you write the quadratic formula, but I'm going to jump into the answers. So x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 20 all over 2 times a, and a is 2. You don't have to show the two negatives, but I want to show that we're plugging in a negative 5 and the formula had a negative. So x is going to equal 5 plus or minus the square root of negative 5 squared is 25 positive. 4 times 2 is 8. 8 times 20 is 160. So minus 160 all over 4. And then we have to do 25 minus 160, and we're going to get a negative 135. So x is going to equal 5 plus or minus the square root of negative over 4. Now, let's see if we can take anything out of 135. Well, since it ends in a 5, we know it's going to be divisible by 5, so it'll be 5 and 27. And 27 is 3 and 9, and 9 is 3 and 3. So we know we're going to have a pair of 3's. So x is going to equal 5 plus or minus the 3 comes out, and I comes out because of the negative. What's left underneath is a 5 times 3, which is 15, all over 4. Now, we're going to break each one up into its own fraction to see if we can reduce. So we get 5 over 4 plus or minus 3i squared of 15 over 4. Since nothing can be reduced here and nothing can be reduced there, this is our final answer. Make sure you have equals x. You definitely need to have that equal sign and the variable. So on number 7, I'm going to let you do whatever method you'd like. I would probably do the square root property, and you should get x equaling plus or minus 9. On number 8, well, it kind of looks like it's factored already, but it's not, because it would need to be equal to 0 if we're going to try and factor and solve. So this is not in a good form, so we need to multiply it out. So x times x is x squared. Outer gives me a positive x, inner gives me negative 3x, last gives me negative 3, and it equals negative 6. If for some reason it would have equaled 0, we would have been good to go and just set the factors equal to 0. But since it didn't, we're going to have to do a lot more work. So combining like terms, that would give me a negative 2x. Add over the 6, and I get a plus 3 equaling 0. Now, a lot of students would be like, yes, it's factorable, but it's not. Remember, we need a positive 3 and a negative 2. There's no way to get a positive 3. If we use 3 and negative 1, that would give me, negative 3 and 1, that would give me negative 2, but not a positive 3. So this actually is not factorable. So be very careful not to jump to conclusions that things are factorable when they're really not. Be very careful with your signs. So A is 1, B is negative 2, and C is 3. So plugging these into our formula, x equals negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 3 all over 2 times 1. So I'm going to let you finish that one off, and that's going to be x equaling 1 plus or minus I square root of 2. Now, why am I getting that 1 there? Because when you separate, you're going to get 2 over 2, and 2 over 2 is 1. So make sure you reduce and simplify by separating first. All right, so last one, number 9. You could do an old way of taking x plus 7 times x plus 7, multiplying it all out. but we haven't done the square root property in this section yet, so let's go and do the square root property. So we're going to take the square root of both sides because we have a quantity squared equaling a constant, and don't forget plus or minus. So x plus 7 equals plus or minus the square root of 40. So then what do we do? Well, what is 40? 40 is 4 times 10. 4 is 2 and 2, so there's a pair, and 10 is 2 and 5, not a pair. So we're going to end up with x plus 7 equaling plus or minus a 2 comes out and a 10 is left. And then we just need to subtract over the 7. And when you subtract over the 7, those are not like terms, so put it in front of the plus or minus. So x equals negative 7 plus or minus 2 square root of 10. So make sure that you know how to use the quadratic formula well, but try some of your old techniques first. Remember, you had 4 different techniques. Factoring, not always going to work. I just showed the square root property. If you want to complete the square again, you can, but we kind of shy away from that in 116. And then the quadratic formula is hugely important because not everything is factorable.